All right, we are starting off with collision theory. Collision theory is going to explain to us the ways that we can increase reaction rate. So, collision theory describes what is needed for a chemical reaction to take place. We know that our particles must collide with proper energy and proper orientation. So, I like to think of this as a high five. If you're going to high five somebody, you're going to hit them palm to palm. Boom, that's a high five. This, not a high five. Not a high five. Not a high five. Palm to palm. And you have to do it with the proper energy. Like, that's a lame high five. I wouldn't even call it a high five, but that's a good high five. So you need proper energy and orientation. I like to call that the chemistry home run. If you think of a home run, you can think of it like the player is hitting the ball with the bat. The hitting is the collision, but we want the batter to hit the ball with enough power, enough energy, that the ball can fly out to the end of the field. And then we also want the bat to hit the ball just right so that the ball doesn't fly off to the left or off to the right. Now, this is going to give us what is called an effective collision. When we have something that hits with proper energy, I'm trying to move my little bubble here and it's not wanting to go. Come on. Oh my goodness, this is so annoying. This is very silly. Move the bubble. Okay, regardless, we're going to get something with proper energy and orientation that's going to cause an effective collision. So if you look here at the bison, these guys are hitting the top of each other's heads with enough power and at the right angle, thus an effective collision. So there are 6 things that we can do to kind of ensure that we're going to get an effective collision. The very first thing is to make sure that our reactants actually want to react with each other. If you try to react salt and water, it's not really a chemical reaction technically. Dissolving would be something physical. But if I were to take water and react with sodium, I would get a reaction. So depending on what our chemicals actually are is going to tell us if they'll react with each other. Remember the noble gases, group 18, those guys will never react because they already have their full valence shell. So that's also something to think about. A lot of the time they're actually used specifically because they don't react. They're sometimes used to increase pressure on a reaction. Because when you add them, they don't do anything. They just take up space. And by taking up space, they shrink volume, kind of, but more or less add pressure. Next thing we can do to ensure an effective collision is to increase the temperature. So as our temperature is rising, particles move faster. And when they move faster, their overall energy increases, giving them good power for the home run high five. Next, we have concentration. If you increase the concentration, you're adding more molecules. Remember, concentration is a measure of how much stuff is in your other stuff. So in this case, how much milk is in this coffee. Increasing the concentration means that there's more particles that are able to have a reaction together. We also have surface area. Surface area is something that we can control, but only for solids. If you remember the factors that affect solubility lab, the sugar cube should have dissolved slower than the granulated sugar, like the spoon picture right here. The reason for that is because the granulated sugar, every single one of those little sugar particles or grains is pretty much able to react entirely with not react with, but be dissolved by the water. Where the sugar cube, because you have layers and layers of sugar, only the outside layer is touching the water. The inside layers are shielded. So it means that if you were watching very carefully, you probably noticed that the sugar cube was sort of dissolving in layers. That's because just the outside was able to dissolve. So it's the same thing if we're trying to force a reaction to happen. If we have stuff in a big lump, only the outside is able to react. And the inside molecules or atoms, they are kind of shielded by everything else. So they would describe this as being ground up, powdered, granulated, smashed, something to that effect, versus a lump, a bar, or a sheet for a small surface area, like a sugar cube. Another thing we have, we can increase the pressure, but only if our system involves gases. Increasing the pressure on a system of solids or liquids doesn't really do anything. But if we are to increase the pressure on gases, what this does is if we're working with gases and solutions, or gases as part of a solution, the high pressure is going to squeeze the gas down and force it to stay inside the solution. Or what we can do is just squeeze our volume, which also increases pressure, and that is going to get our gas particles in closer contact with each other. Absolute last thing is introducing a catalyst. So if we introduce a catalyst, essentially what this does is it provides an alternate reaction pathway, which is a fancy science way of saying it's a shortcut. So if you look at this picture here, we have a person walking through the woods, and there's two paths. This is the same thing that atoms can do. If they're trying to have a reaction, they can go down their typical normal path, and it's going to take X amount of time. Or they can take the shortcut, which uses a catalyst, and it'll usually be a shorter amount of time or a smaller, you can operate the reaction at a lower temperature. It will always decrease the activation energy, but the important thing here is that it is providing an alternate reaction pathway. It makes A meet B quicker so that we can get our reaction done. And that is it for collision theory. It's very similar to the factors that affect solubility. What we want to get is a high five, proper energy and orientation. The two things together give us what's called an effective collision. And there are 6 ways to increase the likelihood of effective collisions: nature of the reactants, increase the temperature, increase the concentration. If it's solids, we want a large surface area. If it's gases, we want a high pressure or a low volume situation. And then we can also introduce a catalyst.